Hey everyone, so in this video we are going to talk about speed of light and time and why we relate both of them. So in this we are going to learn about relationship between time and light, and this was given by Einstein. So there was always a relationship between time and light. So for this Einstein made a new type of a clock to learn what is the relationship between time and light. And like my other videos and previous videos, we have discussed about dilatation of time and how it is related to light. So he developed a two mirror plane and he imagined that a beam of light is oscillating between the two, and that is how he was calculating the time. So whatever I have said is sounding very hard. So let us see it in a chart form and we can learn through that. So now let us see what I was talking about. So in this chart that I have prepared, we will imagine these are the two planes of mirror, and this is a beam of light which is oscillating between these two, and this is oscillating between these two, and that is how we are measuring the time. If this plane is moving, and suppose we are standing here, so we will see the light going like this. And if I am standing inside the mirror, what I will see is simple oscillation because I am moving with it. So this is what we see when we are stationary, when the light is moving, and this is what we will see when we are moving along with the light. So we will call this as, this time we will call as t dash, and the velocity will we will call this as ct. C will be the speed of the light and t prime will be the time that the stationary person is observing. Why? Actually it is speed of the light into time, which actually is in the moving clock. And here we can find the distance also. We all know that distance is speed into or velocity into time. So this will be v t dash, because this time we are following, this person is seeing the t prime or t dash time. So here it becomes a right angle triangle, and we know that in right angle triangle c square equals to a square plus b square. So by Pythagoras theorem we can put it in the Pythagoras theorem, and now it will be c prime square equals to v t prime square plus c t square. We can break this and we can write it c square t prime square equals to v square t prime square plus c square t square. Then t prime square equals to, we can divide this by c square. So when we are going to divide this by c square, what we find is this equation, which will be, again, then what we will do is we will move this t square to one side. So we can find an equation like this, which will be t prime square minus v square upon c square t prime square. Now we can also write this as t square. We can separate this t prime square from both of it, and it will be 1 minus v square minus c square. Now the equation will become, when we remove the squares, it will become t equals to t prime under root 1 minus v square upon c square. Again, we want to see what actually t prime is. That is the time which a person is observing when the person is stationary. In this case, it will be t prime equals to t upon under square 1 minus v square upon c square, or t prime. So this is the final equation which we will be getting. I will explain this equation. This is the time which a stationary body is observing. This is the actual time in a moving body, and v square is the velocity and c square is the speed of the light. And we all know that the speed of light is the maximum speed in the universe, and we cannot reach up to that speed. So v will always be less than c, and it is very less than c. Like if I'm driving a car, you cannot compare driving a car with speed of the light. So V is very less than C. So it becomes 0. When V is very less than C, means C is maximum and V is nearly 0 comparative to it. It will become 0. So in that case, the T prime equals to T upon 1 minus 0 under square. And then T prime will become T upon square under square 1. So this becomes like T prime equals to T. So here you can see T prime equals to T. So what I was talking about is we cannot move at the speed of the light, and this equation shows and gives us an idea that yes, when we are moving at a particular speed, the time may differ or the time will run slow for us. But if we are reaching near the speed of the light, or we cannot attain the speed of light, but if we have attained the speed of light, that means V equals to C. In this case, the time will freeze. If you apply this in the equation, you will see the time is going to freeze. So we learned a big equation today and we have forgotten most of the thing. So just we have to remember one thing, that we cannot attain the speed of the light, and when we are moving fast, you are aging slowly. Thank you.